In this video, I am going to talk about Laplace transform. Laplace transform of a function f of t, okay, is defined as Laplace transform of f of t of s is equal to integral 0 to infinity f of t e to the power negative s times t dt. That's how Laplace transform is defined. By the way, this is an integral transform, so it's important to know that it is an integral transform and a very useful one. Okay, it's used in solving differential equations, particularly ordinary differential equations. So let's look at this indefinite integral. So since this is an indefinite integral, it is possible that sometimes this integral converges, but sometimes it may not converge. If this integral converges, this indefinite integral converges, then we say that the Laplace transform of the function f of t does exist. On the other hand, if this integral does not converge, then the Laplace transform for that function does not exist. So there are a couple of things about Laplace transform definition. So number one, this s, typically we deal with real values of s, but it is allowed to be complex. That means you can have s to be complex. S is allowed to be complex number. That means if needed, you can have s to be complex number. So that is one thing you may want to keep in mind. Number two, integral goes from 0 to infinity. So technically, and we are integrating with respect to t, as you can see, right? So it's going to be that for t greater than or equal to 0, okay, the function f of t is defined. F of t is defined. Okay. Number three, you could have the function defined for t less than 0. In that case, typically for t less than 0, we set f of t is equal to 0. So it does not have any impact on the integral. So this is how we define Laplace transform. Now, this transform is very important, as I already mentioned. It's an integral transform, and it is very helpful and useful in solving ordinary differential equations. Now, one property of Laplace transform is this. It is linear. Okay, it is linear. What does it mean? It means that Laplace transform of, let's say, a times f plus b times g is going to be equal to a times Laplace transform of f plus b times Laplace transform of g. So the Laplace transform follows the linearity. Next, I would like to give you a couple of simple examples of Laplace transform. So let's consider example 1. My f of t is some constant. Let's call it k. In that case, what does the Laplace transform become? So let's say f of t is equal to k. We want the Laplace transform of it. My integral is going to go from 0 to infinity. F of t is k, remember, times e to the power negative st integrate with respect to t. So then k is a constant, so I could bring it outside, right? And then it becomes integral 0 to infinity e to the power negative st dt. Now, the integral of this is going to be k times 1 negative 1 over s times e to the power negative st, evaluated from 0 to infinity. So here I am being a little bit informal. I kind of, to evaluate indefinite integral, kind of technically we have to take the limit, right? So I'm just being a little bit informal. Hopefully it's okay. So this is gonna be equal to negative k over s evaluated from, actually not that, negative k over s e to the power negative st evaluated from 0 to infinity. If you simplify it, what it is going to give you, nothing but k over s. So the Laplace transform of a constant is constant times 1 over s. Now this k could be 1, 2, 3, whatever number, it's a constant, right? So k could be 1, 2, 3, pi, I don't know, e, whatever you want. So it's going to be that number divided by s. So this is a very simple and straightforward example. Now let me give you another example, slightly more involved, but still quite simple. Example 2, Laplace transform of f of t is equal to e to the power a times t. So again, Laplace transform of f of t is equal to e to the power at of s is equal to, again, just follow the definition here, integral 0 to infinity f of t, but my f of t is e to the power at times e to the power negative s times t dt. You are integrating with respect to t. So now what I'm going to do, I'm going to combine things. Integral 0 to infinity e to the power at times e to the power negative st. I could write it as e to the power negative s minus a times t dt. Now again, if I integrate it, it's going to be negative 1 over s minus a, right, times e to the power negative s minus a times t evaluated from 0 to infinity. Again, I'm being a little informal here. I'm not going to the limit for finding the integral, improper integral. So just take it as it is. I just put the 0 and the infinity as lower and upper bounds respectively. So if I simplify it, what am I going to get? When t goes to infinity, that is going to be 0, then minus, and this minus together is going to make it positive. So for 0, t is equal to 0, e to the power 0 is 1, so your answer is going to be just 1 over s minus a. So Laplace transform of e to the power at is nothing but 1 over s minus a. Now, there are some other basic or fundamental functions for which Laplace transform could be found. It's just evaluating the integral gets a little bit more involved, but you should search for or Google Laplace transform table. You will find a list of all the functions for which Laplace transform is done, and or most useful functions for which we need Laplace transform, and you'll be able to use them. But the basic concept or the idea is what I talked about here. How a Laplace transform is defined, what are the restrictions and conditions, and that Laplace transform is a linear operation, okay? And then I have given you a couple of simple examples of how to find Laplace transform. That should clarify your concept, and then the rest is just implementation and doing lengthy integrals. I hope that this discussion was helpful. Thank you very much.